Hey, what's up you guys? Thank you for joining me again. Now in this video, we're going to be covering part 2 of solutions of triangle. So as I've mentioned previously, in this video, we are going to be covering specifically area of triangles. Okay, so without further ado, let us get started. For this chapter, right, there are two main formulas that you have to know. Okay, to find area, there's only two main formulas. The first formula is this: area equals to 1 over 2 AB sine C. Now, where is A, where is B, and where is C? Imagine you got a triangle here. Okay, if you're taking this angle, let's say this angle C. Okay, where is angle A and B? A and B has to be the length of the sides next to the angle. So that means this one is A. Okay, this length here is A, and this one here is B. Okay, you have to take the two length that is next to the angle. So if let's say your angle is here, let's say you are looking for angle B. Okay, when you're looking for angle B, the length you're taking is A, and also here there's one more side here, C. Okay, I'm calling this C. So you're going to take A and C. Okay, so make sure you use the correct length and the correct angle. Just remember, the angle that you're looking for, that you want to take, you have to take the side, the length that is next to it. Okay, that means the two length next to it. So that's the first formula for area. The second formula is what we call as Heron's formula. So Heron's formula is like this: you have square root S times S minus A times S minus B times S minus C, and then you square root the whole thing. Okay, this is Heron's formula. Question is, how do you find S? What is all this S? Okay, so let me show you what is S. S, okay, not ASS, huh? S is, you take length of the triangle A plus B plus C divided by 2. Okay, this is how you find S. So imagine if you have, if you're using the same triangle here, right? Let's say you're using for the same triangle here. A, B, C are the length of each of the sides. So A here, B here, and C. Okay, and you want to find S, you take all the length, add them together, divide by 2, which is this. Okay, once you have found S, you substitute here, and then the A, B, C is the same thing, substitute, and you can get your answer. So the question now is, when do you use A and B? Okay, I mean A and B as in the first formula and the second formula. When do you use it? So the first formula you use when you have one angle and two length next to the angle. Okay, so you have to have one angle. So if let's say you got a triangle here, if you're using this angle, you must have this two length. Okay, if you have this, let's say you don't have this one, let's say you have only these two here and here, you cannot solve, because why? You don't have this, you need this angle. Okay, if you want to use these two, you have to find this angle instead. You have to use that angle. All right, so make sure you have one angle and two length that is next to the angle. Okay, side by side. The next formula you use when Heron's formula, right here, Heron's formula, you are using this when you have all the lengths of sides. Okay, all three sides of the triangle, you have the length. When you have all three length, then you can use this formula. Okay, there is no angles involved. Okay, Heron's formula got no angles involved. So that is the two formulas that you have to know for this chapter. So let us go straight to some examples. The diagram on the right shows triangle BCD and triangle ABD. Find the area of triangle ABD. So ABD is here, correct? So again, there's only two formulas, right? It's either you use the first formula, that means you need one angle and two length, or you use the second formula, which you require three lengths, okay, three of the sides. So in this case, since they already told you that this is same length, that means they're isosceles triangle, correct? So if this isosceles, so that means here also 10 cm, correct? So if you already have these two lengths, obviously you can use, if you can find this angle, then you can form use your first formula, correct? One angle and two sides next to it, correct? So how do you find that angle? So if you notice, here is 55, so here also should be 55 because it's isosceles triangle, right? Same length, so here both should be same angle, 55. So you can find your angle, this angle, correct? You can find it. You can take 180 minus 55 to get this angle. Then 180 again minus this and minus this, you get this angle that you're looking for. Okay, but I'm going to use another way, which is, I'm sure you all learned before in the past that when you have a triangle, when you get the external angle of one of the sides, right? Let's say one of the angle here, this external angle is 100, let's say. This 100 is actually equivalent to this angle here, let's say this A, plus this angle here, let's say this B. These two angles plus together should be equal to the external angle. So in this case, you notice that here is 55, right? 55 is the external. So the 55 external is equivalent to 24.18 plus this angle that you're looking for. So to find that angle, I can actually use, let's say angle ABD is equals to 55 minus 24.18. So you should get 30.82 degree. Okay, so that's angle ABD. So now you can find your area. 1 over 2 AB sine C, right? So where is A? A is this, B is the two length that is next to the angle. So 20 times 10 sine C is the angle, which is 30.82. You key this in your calculator, you get 51.237 cm square. Okay, now you might get a different answer, maybe certain decimal different. If it's not too far from this answer, it's fine. Okay, but if you get like 52, then it's something else. Okay, you should get at least 51.23 something. Okay, so this is your answer. Next, the diagram on the right shows two triangles EFJ, EGH. Okay, and then EFG and EJH are straight lines. Calculate the area of the shaded region. So in this case, they want you to find this area, correct? But like I said, this is what? This is not a triangle, correct? How is this? This is not a triangle. So you cannot just find the area directly. You have to first find the big one, the big triangle, minus the baby one, okay? The small triangle. So we're going to do that. So in this case, which formula are you going to use? Are you going to use the first one? That means 2 length 1 angle, or are you going to use the 3 length formula, Heron formula? Obviously is Heron's formula. Why? Because there is no angle involved here. They never state any angle. So the easiest way is to straight away use the length formula, because you know all of this length, correct? You know all the length, so you can use that formula. So in this case, to use that Heron formula, you need to first find the S value, correct? Find the S. So in this case, let's say we solve J first, J triangle JEF. Okay, the small triangle here. Okay, the S value, let's call this S1. So S1 equals to 5 plus 5 plus 9 divided by 2. Okay, so you should get 9.5. Okay, and then the triangle, what's the big one? The big one would be HEG. Okay, the big one here, HE and G. Okay, is, let's call this S2. Okay, so here is, let's count. So here the total length is 11 cm. Here the total length is 12 cm. here would be 5 cm. Okay, so it's equivalent to 11 plus 12 plus 5 divided by 2. So your answer here should be 14. Okay, as 2. So now you can find the area. So area, remember, you have to take the big one, right? So the big one is HEG. So you take S, the S is 14, right? S, and then 14 minus the length. So 14 minus 11. Okay, I'm just going to write here just in case you don't remember. Area formula for Heron is square root S, S minus A, S minus B, S minus C. Then square root. Okay, ABC are the length of the sides. Okay, so in this case 14 minus 11, 14 minus 12, 14 minus 5, and then you square root. Okay, and you're gonna minus, okay, wait, let's say area of shaded region. I'm going to do the whole thing in this one calculation. Okay, minus the baby triangle. So in this case is 9.5 times 9.5 minus 5, 9.5 minus 5 again, 9.5 minus 9, square root the whole thing, equals to, you should get 6 square root 21, okay, for the first one, minus 9 square root 19 over 4. I'm just using the calculator actually, so that's the answer that I got. And the final answer is 17.6879 cm square. Okay, so just use the formula, you should get the answer. Alright, next, Mr. Sammy wants to paint the wall of his room. He draws a triangle, okay, on the wall, okay, shown on the diagram on the right. The length of the sides, okay, so you see they gave you length in terms of x, correct? And then they tell you the area, they gave you the area. Find the value of x. So in this case, it's very obvious because you don't really need, there is no angle involved, right? So you know you cannot use the first formula. So you can only use Heron's formula. So first thing, Heron's formula, make sure you find the S value. S value is 2x plus 4x plus 3x divided by 2. Okay, you should get 9 over 2x. Is that correct? 359, correct. So 9 over 2x. So that's your S value. Now you want to find your area. So area, since they already gave you here, so you write square root 135, the area is equivalent to 9 over 2x times 9 over 2x minus the length, right? So 4x, and then 9 over 2x minus 2x, 9 over 2x minus 3x. Then don't forget to square root. So what is your answer? So here you can cancel because both sides square root, right? If you don't know why I can cancel, you can actually square the whole equation and then you eliminate the square root. Okay, so 135 is equal to, here you get 9 over 2x times 1 over 2 x times 5 over 2x times 3 over 2x. Okay, so this is your, and then you simplify this, you get 135 equals to 135 over 16x power 4. Okay, so I'm going to write here. So in other words, x power 4 is equals to 16. Rearrange that. So x is equals to fourth root of 16. Answer is 2. Okay, so this is how you find the x value. In other words, you're actually just reversing the process because they gave you the area already. Okay, so next, Mr. Khan won a tender to install carpet in an office. Calculate the area required to fill up the office space as shown in the diagram on the right. So in this case, okay, they want you to find area, correct? But in this case, it's not even a triangle. So if you start using the formula, you cannot get the answer for sure because it's not even a triangle. So now how do you solve this then? You see, the only way you can solve this is you have to make it become a triangle. So in this case, you can draw a line. So let's say I draw a line here. Okay, let's assume this is a straight line. Then you have now two triangles, here one, here two. So if you want to find the area, you just have to find both area and add them together. Okay, so the first area for this side you can find. Why? Because it's a right angle. Right angle is very easy, right? You don't even have to use the formula. You just use 1/2 times base times height. You can find this area. But what about this area? Are you going to use the first formula or the second formula? So in this case, you can use either one if you can find the angles. Okay, if you can find the angle, you can use the first formula. If you can find this length, okay, the length of this line, then you can use the Heron formula. So it depends which one you prefer. But in my case, I would use Heron. Why? Because I can easily find this. How to find? It's the hypotenuse, right? Hypotenuse of this right angle. So it's actually pretty straightforward. So you just find the hypotenuse. So let's say this is h lah, okay? Hypotenuse. So h is equals to 16 square plus 20.5 square, and then you square root. Your answer should be 26.008 something. But I'm just going to use 16, okay? I round up to 16. So 16 meter. 26, sorry, not 16. 26 meter. Now, you can start finding for the area. So area is equals to the first triangle, the right angle is 1/2 times base is 20.5 times height is 16. Okay, plus how do you find the second area there? You have to first find the S value, right? So S value, Heron's formula, right? Don't forget. S value equals to 26 plus 18 plus 11.5 divided by 2. So what's your answer? Sorry, let me calculate. 26 plus 18 plus 11.5 divided by 2. You should get 27.75. Okay, so you're going to use the formula 27.75 times 27.75 minus 16. Sorry, not minus 16, minus 26. I keep saying 16. 27.75 minus 11.5. Oh my god, no space. How do I write this? Let me erase this part. And then another bracket is 27.75 minus 18. And don't forget to square root. Okay, square root the whole thing. So in the end, you should get your answer is 251.716. Okay, somewhere here, somewhere around this answer. Meter square, don't forget. Okay, so the main thing is find the area for the first triangle here plus the area of the second triangle. You get your answer. The diagram on the right shows a decoration in the shape of pyramid. The decoration has triangle base. Okay, vertex V is vertically above vertex P, so that means this is a vertical line. Okay, this is a vertical line. So if it's a vertical line, then here should be 90 degree, right? It's a right angle. And then they tell you that PQ is 4 cm, PQ is here, PV is 10, VR is 15, VQR is here. Okay, this angle here is 80 degree. Calculate the area of the inclined surface of the decoration. So that means they want this. Okay, the inclined surface. So how are you going to find this? So if you look at this, right, you see there's only two ways for you to find area, correct, in this chapter. Either the first formula or the second formula. First formula, you need two length, and then in between the two length you have the angle. So in this case, if you're using 80 degree, you need to find here and need to find here. Problem is, this one is a bit hard to find, right? Line QR is a bit hard to find. Line VQ is easy because it's a right angle, right? You can just find the hypotenuse. But now you want to find QR. So QR is a bit hard. So if you want to use, let's say you want to use the first formula, the area formula, 1 over 2 AB sine C, you will need, see, if you can find this hypotenuse, you got this length and this length, correct? So all that's left for you to find is this angle. If you can find this angle, then you can solve. Problem is, how do you find that? So you can use what we have learned in the previous chapter, the previous part 1 video, which is sine rule. Because here you have one pair of angle, here you can find the second pair, right? You can find this angle, then 180 minus these two, 80 and minus this, you should get this angle. You can do that, okay? Another way you can do is, if you want to use the second formula, Heron formula, then you need to find the length QR. So how do you find length QR? Since you are given this 80, you can use cosine rule, okay, to find QR. Now, since I don't want to complicate too much, okay, for you guys, so I'm going to use the QR way, okay, the cosine rule. Then you all see how you all can learn from this, okay. So in this case, let's first find the hypotenuse. So VQ equals to square root of 10 square plus 4 square, and then you square root, okay. Answer should be 2 cert 29. Okay, I don't want to write in decimal first, because if I write in decimal, I need to round up. So when I round up the number, it will be a bit different from the actual answer. So I try not to round up so early in the calculation. Okay, I can round up by the end of the calculation, that's fine. Okay, but don't round up too early in the calculation. So this is VQ, okay, 2 cert 29 cm. Now you want to use cosine rule, right? I said. So remember what is cosine rule? In case you don't remember, a square equals to b square plus c square minus 2bc cos a. Okay, because I want to find QR, right? QR is the length, so I'm going to use the first formula of cosine rule. Okay, so in this case, let's see. So if let's say I'm using cos a, so that means this is cos a, this is the angle. So my B is what? This would be B, this would be my C, this would be my A. Okay, so you can rewrite this 15 square equals to B square. What is B? B is 2 cert 29 square plus C square is, which is what you're looking for, so it's QR square, minus 2BC, 2B and C, which is QR again, cos 80 degree. Okay, so you rewrite this, you should get, you can expand, right? 2 to 5 equals to 116 plus QR square minus 3.7405 QR. Now I try to use as many decimal as possible so that I get closer to the actual answer. Okay, and then now you can simplify this, you can rearrange, so you get QR square minus 3.7405 QR plus minus 109 equals to 0. So now this is a quadratic equation, right? You got the QR square and then the QR and then a constant. Okay, so it's a quadratic equation, so you can get two answers. Okay, your first answer is QR is equals to 12.4767. The second answer is negative 8.7363. So obviously this one you can ignore because it's a negative. You're not going to get a negative length, right? QR is the length, right? So now you have all three lengths. You can use your Heron's formula, or you can use your what's that, the first formula, which is the AB sine C, because you have the angle, you have the two lengths next to it. So in this case I'm just going to use that, okay, because it's much easier. So the area equals to 1 over 2. A is what? AB sine C. So in this case the A should be the hypotenuse, which is 2 cert 29. B is the C value here, which you just found, which is 12.4767 sine 80 degree. Okay, so you put in your calculator, you should get 66.169 cm square. Okay, something like that. Okay, this should be your answer. I hope you find this useful, right? I hope you can understand this. There are many ways to solve this. This is one of the way. It might seem complicated. I would suggest, if you cannot understand this, go for the sine rule one. Okay, sine rule is much easier. Okay, so yeah, that's how you solve this kind of question. Let's see the next one. The diagram on the right shows a children's toy in the cone, and upper portion is cut off. Surface circle, radar horizontal, OP is vertical. Okay, so OP here is vertical. And then what they're saying, OA is 5 cm. Okay, OA is 5 cm. PB, where is PB? PB is 10 cm. OP is 16. And then BPQ. So this angle here is 90 degree. So I want you all to see this. It doesn't look like 90 degree, right? So in other words, the drawing can sometimes be very deceiving. Okay, when I first saw this, I didn't know there was 90 degree until I read this lah. Otherwise, I would think it's more than 90 degree. I would think it's an obtuse angle, but it's not. It's a 90 degree. So the drawing can sometimes be very deceiving. So take note of that. Okay. So now the question, they want you to find length AC. Okay, if you all want to try it yourself, please, you can pause the video and try it. Okay, so in this case, how do you find AC? AC is here, right? So the one way you can do is you can extend a line here. Okay, and you can see you have a triangle here. Correct? You have a triangle here. So how do you find this vertical line? Should be same as this, so it's 16. So the vertical you already found. And then here, how do you find this hypotenuse, this angle? See, I just said the answer. It's a hypotenuse. Why? Because here is another triangle here. I don't know whether you can see this or not. Wait, it's another triangle here. Okay, the base of the triangle. So let me just redraw for you. So here is a triangle. The side here is 5 cm, same as the top here. So here's a 5 cm. And then here would be the other side should be the radius, correct? So radius is 10. So now you can find the hypotenuse. So this one is the hypotenuse. Okay, so let's find that first. So h is equals to 5 square plus 10 square, square root the whole thing. Then your answer should be square root 125. Okay, so square root 125 is h value. Now you want to find AC. So AC is what? AC would be equal to square root. It's you can use Pythagoras theorem. Okay, so 16 square, because here is 16, right? 16 square plus square root 125 square, then you square root the whole thing. Okay, here you can cut. So in the end, you should get your answer is 19.5192 cm. Okay, this is your answer. Then question B, area of plane ABC. So where is plane ABC? So I'm just going to erase this first so that you don't get confused. So plane ABC is here. A, B, okay, this one. Okay, so you have already found AC, correct? Which is this one. Okay, but by the way, you can actually write, you can write in terms of cert. The cert answer is 831. Okay, I'm using 831 in this calculation so that I get a closer answer to the actual answer. Okay, so in this case, you already found AC. AB you can find. How are you going to find? You can use another triangle here. right? So you got a small triangle now. Here is 16, here is 10 minus 5, so here should be 5. Okay, so let's say this is let's say this x. Okay, so first you want to find x. X equals to no need to write x, that is AB, right? Is AB. So AB equals to 5 square plus 16 square square root. Your answer should be cert 281. Okay, unit sorry, not unit, cm. And then you want to find length BC. So BC, if you notice, there's also another triangle here. Okay, there's another triangle there as well. So it looks something like this. It's very tricky because you can't really see it's a 90 degree, so you won't think it's a 90 degree there. So it's a bit hard to see. So here is 10, here's a 10. So you can find BC. So BC equals to cert 10 square plus 10 square. Answer is 10 cert 2 cm. Okay, so this is your BC. So now lastly, you can use all this length to find your area. So you're going to use Heron's formula. S equals to cert 281 plus 10 cert 2 plus cert 381, which is this one here. Okay, divide by 2. Answer is 25.2122. Okay, now you can find your area. Area of ABC is equals to square root, S value is 25.2122. It's going to be pretty long, 25.2212 minus which one? Minus 281, and then 25.2212 minus 381, and then 25.2212 minus 10 cert 2. Then don't forget to square root the whole thing. You should in the end get your answer 5 cert 537, which is also equals to 115.8663 cm square. Now don't be afraid of this kind of question. Okay, it looks complicated, but once you get the hang of it, you can do it. Okay, no worries. It's just that this triangle here, this 90 degree, it can be tricky because it doesn't look like a 90 degree. Okay, so maybe you cannot visualize it. Okay, but these are some of the harder questions lah, no worries. Okay, alright, let's see our final question. So in this case, what, it's a vector question, right? You see they say what, the position of two towns A, B are shown in the Cartesian plane. Okay, you got a Cartesian plane here. Find the angle between position vector town A. So town A, you see it's a coordinate, right? So what's the position vector? -4, 3. Okay, that's the position vector. And then town B is 1, 1. So this one is what? 1, 1. The column vector, right? I write in the form of column vector. Hence find the area of the region in the shape of triangle OAB. So O is here, A is here, B is there. So you get a triangle here. Right? So you got a triangle. So now, what you notice is that you can actually find the length, right? We learned in the vector chapter. How do you find the length of the vector? You just find the magnitude, correct? So magnitude OA, let's see, OA. OA is equals to -4 square plus 3 square, and then you square the whole thing. You should get 5 units. Okay, 5 units. And then you want to find unit vector OB. 1 square plus 1 square, square root. Answer is square root 2 units. Next, you want to find, so in this case, is it possible for you to find use the first area formula, which is A102 AB sine C. Can you use the angle? Is there any angle that you can use? Answer is no. Correct? You cannot. So in this case, you can only use Heron's formula. So that means you need all three lengths. So how do you find length AB? So this is you have two coordinates, right? So you can just straight away use the formula. So AB equals to, remember how to find length? In case you don't remember, let me just write down. Length equals to x2 minus x1 square plus y2 minus y1 square, then you square root. Okay, this is the formula. So in this case, I'm going to use negative 4 minus 1 square plus 3 minus 1 square, then you square root the whole thing. Answer should be cert 29 units. Okay, now you can use your Heron's formula. So first find S value. S value equals to 5 plus cert 2 plus cert 29 divided by 2. Answer is 5.8997. Okay, then you can find your area of OAB. So okay, I'm not going to write all the values because it's too long. So S minus A is what? A is 5, and then S minus cert 2, and then S minus cert 29. Don't forget to square root. So your answer here should be 3.5 unit square. Alright, so that's how you solve this kind of question. So it's actually a mixture of vector and also solutions of triangle. Okay. Alright, so that is all from me. Thank you so much for going through this whole video with me. And yeah, we have basically covered all of this chapter, solutions of triangle. If you find it useful, of course, I would really appreciate if you can like, subscribe, and also share it with someone who will find it beneficial as well. And do let me know in the comment if this is really helpful or you think this is not helpful at all. Just be honest with me. Let me know in the comments so that I can improve and become better. Alright, so I really appreciate your feedback, and thank you so much, and I'll see you on my next video. Take care.